Good morning everyone. Today we are going to start with the concept of real depth and apparent depth. So as we have seen in the previous lecture, say it's a boundary. This is air, this medium is air and this is water. Okay, this is water. Now say a coin is placed here. This is a coin, a 5 rupees coin. A coin is placed here at the bottom, okay, and the light ray is coming from water to air, means it's going from denser medium to rarer medium. Now look here, the light ray is going from denser to rarer. This is water which is denser than air, correct? So light ray is going, so the light ray one which is going straight with the normal, it's like this, okay, it's going normal, straight. Another light ray which is going from here like this, okay. Now say this is the normal drawn over here, okay. When light ray passes from denser to rarer medium, how it goes? Yes, it moves away from the normal. So as it is going like this, it will move away from the normal. And here is our eye. So how do we see? How do we see? We see the light in a straight line. Okay. So when I extend this light ray in the straight line, okay, I find that this coin is placed over here. Okay, you will see that when you will look from here, you will find that the coin is placed, whereas the real place of the coin is here. But you will feel that the coin is raised to this height. Okay, so this is the real depth of the coin and this becomes the apparent depth. Now say the real, see, and the depth whenever you will measure it from the boundary, from the surface, remember, not from here, from the boundary. So from here if I measure, say this distance, this real depth, let's see, say it is D. And this is the apparent depth, okay, say this is D dash, okay. Now this is normal and the angle which is made with the normal, it's angle I, angle of incidence. So this is I, look at this. Now remember this, we are talking about paraxial rays, the rays which are parallel to each other, which I have already explained to you. What are paraxial rays, you are aware of, right? So these angles will be very, very small. Now this is I, look at this, look the Z, can you see the Z? Properly, this is I, so this angle also would be I. And with normal, the angle which is made is angle of refraction. So this, see, again you see, this is R, okay. So this, okay. So this is also R. Can I see that? Okay. Now looking at this figure, let's apply Snell's law. Let's apply Snell's law in it. Now say the refractive index of this medium is N2 and the refractive index of air is N1. Always remember, N2 is the refractive index of the light from where of the medium from where the light is coming, and N1 is the refractive index of the medium where the light is reaching or going. Remember that. N2 is the medium from where the light is coming. N1 is the medium where the light is going. Okay, so now with the Snell's law, I have N2 sin I. You know how to apply the Snell's law? The refractive index of that medium and the angle of angle of that particular this, like here it is sin I. So N2 sin I is equal to N1 angle of reflection, that is sin R. Is that clear? Now N2 sin I is equal to N1 sin R. Now as we know that the rays are paraxial. Rays are paraxial. So the angles become small. So what happens? What happens, tell me? Sin I, yes, is equal to I is equal to tan I. Similarly, sin r equals to r equals to 10r. So may I write instead of this n2 10r equals to n1 10r. Correct? Now see here. What will be 10r? Say this distance be x. Say this distance be x. So what is 10? 10 is perpendicular upon the adjacent, right? So this will be x, and what is this depth? D. This complete thing is d. Can you see? This is x. So what can I write here? N2 x upon d is equal to n1. N1, what will be 10r? Now tell me 10r. This upon this. This is the opposite, and this is adjacent. So opposite is x, adjacent is d dash. So can I write here x upon d dash? X goes. So what I am left with? N2 upon N1 is equal to, yes, N2 upon N1 is equal to d upon d dash, which means, what is d? What is d? Tell me. It's the real length. Okay. Divided by, what is d dash? Apparent. Apparent means false. Apparent depth. So here we are with the derivation of real depth versus apparent depth. Is it clear? Thank you.